Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer tax-deductible donations to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for exam FM on financial mathematics. My exercise number 254. Consider a 100 par value 15-year 4% bond with semi-annual coupons. The bond is callable at 109 on any coupon day starting 5 years after issue, at time 5 exactly, for the 5 years that follow, and then at 105 starting 10 years after issue for the 5 years that follow, except for the maturity date when the bond matures at 100. What is the highest price an investor can pay for this bond to be assured of a yield of 5% convertible semi-annually, no matter whether the bond is called or not? So here's the solution. An investor who buys this bond has these alternatives: receive 109, the first call price paid at time 5, or at time 5.5 or 6, etc. until time 9.5, plus all the $2 coupons through the date when the bond is called. The coupons are $2 per half a year, which represents a 4% annual coupon rate. Or receive 105, the second call price paid at time 10 or 10.5, etc. until time 14.5, plus the $2 coupons through the date when the bond is called. Or receive maturity payment of 100 plus $2 coupons through maturity. If the bond is called at time 5, the rate of return is 5% compounded semi-annually, and the rate of return is 5% compounded semi-annually, then the appropriate price at time 0 is $2 coupon paid over 10 years, so over 10 periods of 5 years, 10 half-a-year periods. So A angle 10 at 2.5%, that's 5% compounded semi-annually, so 2.5% per half a year, plus 109 times 1.025 to a negative 10, and that's 102.65. If the bond is called at time 5.5 and the rate is 5% compounded semi-annually, then the price is 102.10. It's the same method of calculation, but over 11 periods. Note that this price is lower because the bond is selling at a discount, offering income of 2 per half year, while the market yield is 2.5% per half a year. If the bond were amortized, this difference in income would be covered by the amortization process, but in this case the call price remains the same until time 10, so the price resulting from any call before time 10 would be no more than that 102.65. Now, if the bond is called at time 10, its price at 5% compounded semi-annually will be $2 coupon paid over 10 years, so 20 periods, at 2.5% plus 105 discounted at 2.5% per half a year over 20 periods, so 95.26. This is, of course, lower because, just as we just argued, deferring the payment lowers the value of cash flows, as income produced is lower than the market yield. But here we also have a lower value of principal paid, going from 109 to 105, because the call price is different, so the price is significantly lower. Later calls will only lower value by the same reasoning as above. Finally, the price for the case of waiting till maturity is $2 paid over 30 half-a-year periods at 2.5% and $100 discount. So it's 89.53. Each value corresponds to a specific outcome, and in that outcome, there is the price at 2.5% per half-a-year yield. Now, if an investor pays in that specific outcome a price that is higher than the one named, such investor will receive a lower yield, and if the price paid is lower, the yield will be higher. In order to get at least 2.5 per half year in all of those possible outcomes, The investor must pay only up to the lowest of these those prices we just calculated, so 89.53, which is answer A. Please remember, this is copyrighted material. The problem was written by me, created by me, and the solution is mine too. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.